Hello friends, today we are going to learn a tutorial based on timers in PLC. For the same, we are going to use again the software called TI Portal V13, a Siemens software, and the basic PLC will be SN1200. In that, the module we are using is S71200 CPU 1214C DC, which we have already created in our previous videos. So today, I am not going to show you how to create a program from the base. We are going to use our previous program and add timers in it. Today's session will explain you how many types of timers are available in TI portal and how to use them to create a logic in a PLC. So we will begin now. For our tutorial, I can take any kind of program, that is 0 or 00. So I will take 00. Yes, so in this, if I double click, I will say that this is opening the project. Okay, now we have a portal view open. I will go into project view, double clicking, it will open the project view for me. Basically, why we need timer? We need timer so as to give a delay for any activity to happen. It can be something like you want to on a particular thing after some delay. It can be a thing that you want to on a particular output for a particular time only, or there can be a situation that is you want to on a output for some particular delay after some activity is done. For example, the things where it's very simple to understand. Actually, it is on delay. The delay which ons the output or makes the output high after some time is called as on delay timer. So on delay deals with after the delay the output is high. Vice versa, for off delay timer, the thing is the output will be off after a delay specified. Okay, that means in on delay timer the output will be on after a delay, and in off delay timer the output will be off. Yes, that means it is on right now. It will be off after some delay. It is called off delay timer. About top of it, there is again a separate timer. That is, for example, if as you all know, we have clock memory in our PLC. We develop it. That is 1 second timer, 2 seconds timer, and all that. So if there is something that you want to make that output high for just a second, then you can use a pulse timer. Yes, the pulse timing is configurable. You can configure it as per your convenience. That is same as that of inputting some integer value. Yes, so now we will directly start into our implementation segment. Yes, so this is our CPU 1214C DC. I will open the program blocks. Okay, the program is on. So I have used on delay here. I will delete it now. Now see, this is a clock memory used. This is a blink. Okay, that means every second the blink output will be on. Here we have used input I 10.0, that is pump start. Pump will start immediately as soon as this input is high. Yes, if this input is high at 10.0, the output Q 0.1 will be high. Now we'll completely deal with this only. how to make this on and off after a delay and all that. Okay, so first of all, let me introduce you to the timers. Go into basic instructions, open the timer instruction. Yes, so this four timers actually. This is same method of on delay, only thing is a bit difference that I will let you know. So the first one is generate pulse, second one is generate on delay, generate off delay, and accumulator. Okay. Now we will first of all take a on delay timer. Yes. So basically I will use it here. In this session we will be using only the instruction. Since we are not going to connect it directly to the PLC, I'm just going to explain you how this timer block actually works, and in our coming sessions we will explain you the actual functioning of this on delay timer. So now, as I have just dragged and dropped this into this rung, or you can say a network, immediately it took a instance dB. So this dB is called instance dB, which comes along with this on delay timer. This is a feature of S7-1200, or you can say about TI portal software. It automatically gives a instance dB to my timer. So this is the thing, that means if you go in system blocks, program resources, and you can see it is observing here. Okay, for your sake I will open it for you. Say open. Yes, so you can see very closely it is ST time, PT time, ET time, running, in and Q. Okay, these are the things which are required. Now this is a very general instance dB. So in our on delay timer we don't have ST, we are only having in, Q and PT and ET. So what is the function of in, what is the function of Q, what is the function of PT and ET? Let's now explain in detail. As you all know, on delay timer is used to delay a output. Consider the above example only. I have a start button, that is I want to start a pump. So I will start the pump by the button, start button. But if my requirement changes, that I will be inputting, that is I will be pressing the start button, but my pump should not on until unless a specified delay occurs. Yes, so at that time this timer will be used. Now I will just move this here. You can again drag drop. Okay, yes, it is available here. Now why I moved this? Because for a timer to actuate there is an input signal. So this will act as an input signal to this timer. If you don't specify the input signal, it is not going to work. And then it is very but obvious that is there should be some output. This is either you can use this here, or I will show you another method to use this. Okay, it's not compulsory that after T on at the Q output you should use this. Even if you leave blank, then it also okay. Okay, then this is PT. Now as we all know that we have to delay the output, that means there should be some procedure to enter that delay, and that delay is called PT, that is preset time. So here you can enter a integer, for example 5 seconds. Yes, so TA is a bit cleverer, so it will take the rest care of all the syntax and all that. We do not worry about t hash phi s, because t hash phi s is the syntax for the timing value to be entered. If I just entered 5, it will tell you it is 5 milliseconds. See, I'm entering just 5, so it's 5. So by default it takes the milliseconds value, and this is ET. If you want to read, you can read. But now what the question arises, that what should be the data type? Yes, so data type, if you want to know what is the data type of this ET, that means either you want to write their MD, MW or something else. So if you go nearer to it, it explains out is time, double integer or double word. Yes, so it accepts only these 3 types of data words or data types. So I will just click here and say MD 50. 50 is a random value. You can take any value provided it is not used in your program. Yes, so that means there should be no overlap. This is the way my on delay timer works. Now when I press this one, my timer starts executing. After 5 seconds delay, the pump will be on. What will this ET do? It will count down, that is 5, 4, 3, 2, 1. Okay, and PT will go 1, 2, 3, 4 and 5. It's completely reverse as that of PT. Okay, now as we don't have, you just are going to save the project, click on this and say download. Okay, that's it, nothing more to do with it. Now as we don't have the actual PLC with us, so I will just explain you with the help of the waveforms, okay, how it actually works. So changing PT has no effect while the timer runs. That is, when an on delay timer is being used, PT, if at the start it was 5 seconds and you change while the timer is running, it is not going to change. That is, it not going to affect the timer. It will count that much time. Changing into false while the timer runs, that means if the input changes from 1 to 0, the timer is going to reset and stop the timer. Okay. Now I will just move down a bit. See, we have the waveform here. Oh, sorry. I'm using a Siemens manual only, nothing different. This is not my created. Okay, so we have a information like this is my input. So once my input goes from 0 to 1, what happens exactly? See, come down, the ET starts increasing. Even the PT waveform will be the same. It's rising, rising, rising till the PT time. That means if this PT is 5 seconds, so after 5 seconds the ET will remain 5 seconds and the output will be high. Till what time will it be remain high? Till my input is high. I will repeat it again. It is very basic question when an interviewer asks you how a on delay timer works. See, when my input is high, in our case start pump start input. If pump start input is high, my ET will start increasing, go on increasing. Yes, PT will start increasing, ET will also start increasing. But my pump will not start. My pump will start only after the PT elapses. So the PT is elapsed. Now this is, it will go on and it will make the output high. Now this will be done. Okay, fine, the output is high now. But till what time will it remain on? It will remain on for the falling edge of my input. If my start pulse, that means my input, that means my pump start input I 10.0 goes 0, immediately my output is going to go 0. Okay, this is one case. The other case, which we read now. So now my input is 1. Okay, fine, it is 1. The PT has started, but due to some problem the input goes to 0. That means pump start input goes to 0. What happens? What happens is it goes to down, the timer changes, okay, that is PT goes to 0, and there is no rise in the output. There is nothing happening. Again the timer starts, my input pulse, the PT rises, it rises and it rises and it continues after the PT is on. So the on timer sets output Q to on after a preset time delay. Okay, fine. Now let's move on to the pulse timer. Before going to the actual block diagram, we will just have a look on this timing diagram. This is called timing diagram. So a pulse timer, the TP pulse timer generates a pulse with a preset width and time. That means it will be on for a particular time only. Why I am immediately showing you this? Because it's very similar to that of the on delay timer, but a very basic difference between these two lies here. See, now the input is high. Yes, it is high, continuous. The preset time is increasing. Okay, at this moment the preset time hasn't been increasing. The output remains on. It is not on after, it remains on for that particular time, and as the timing elapses the output goes to 0. It is irrespective of my input signal. In case of our on delay timer, if my input goes to 0, the output stops working, whereas that means output or either my timer stops working. But with the case of my pulse timer, once it gets a pulse, irrespective of its 1010 transitions, my timer is going to operate at that PT. So this was the case that it is the input is high, it remains high, my PT is starting, my PT till my PT is rising, my output is high. Once my preset time is over, it goes down irrespective of my input signal. We will move to the next situation, that my input goes high, my PT starts. Yes, my PT increasing also starts, but in between a transition of 1 to 0 comes, then 2 my PT works, my output still remains on for that purpose. Yes, so it is, even though in a single change it 1 to 1 2 happens, that is 2 to 3 transitions happen, till my preset time it is going to not at all affect my output. So this was my pulse timer. Let's again explain the off delay time. I will show you the ladder diagram. It's very simple to understand the ladder, but it's very hard to understand the timing diagram. Okay, fine. So we will come to this later on, but for this today, right now we are going to explain this one. Okay, now we learned TP, that is pulse timer. We learned on delay timer. Now we are going to discuss the off delay timer. How off delay timer works? Off delay timer means the output will be off after a particular delay. Yes, so the off timer resets output Q to off after preset time delay. Now this is the input signal 1. A very major change between on delay and pulse timer and off delay be that the off delay timer starts its function after 1 to 0 transition. That means my input should go 1 and then go to 0, then only my output will be, or my timer will start counting. Okay, see very clearly. Now once my input goes from 0 to 1, my output is high. Yes, my output is high. Then it's high till this point. It goes, the input goes from 1 to 0. My timer starts counting. That means timer is working now. Till the preset time, it is going to make that output high and go to 0. Again go 1 when there is input. Again come down and my timer started. Yes, the output is high. Then it is not going to go to 0 because the input has changed to 1 again. So in pulse timer, there is a point that input, let it be the input changes from 1 to 0 number of times. Once my timer has started working, it is going to count the preset time and work accordingly. But with respect of my on delay and off delay, if my input changes, in case of on delay timer, if the input changes from 0 to 1 while my timer is changing, or 1 to 0, in between my output changes. In on delay timer the output becomes 0, and in off delay timer the output becomes 1. Okay, this is a very basic difference between on delay and off delay and pulse timer. Okay, so first of all, going ahead, I will explain you how to add these two blocks into our timing blocks. Okay, let's come down. So for doing it, either you can use a toggle switch, okay, like this one. Okay, so I will show you that. So your instance DB comes, I say okay. You can either go manually and also add and change the name. You can do that. Or here also you can click and say yes. Again provide the time in seconds. So this pulse will be, that is this output will be high for 4 seconds when my input goes 1. If it goes from 1 to 0 also, then 2, my output will be on for 4 seconds. Okay. If you want, you can add the ET time, but as we are not dealing with ET anymore, so I am not going to write anything. If you want, you can write, but no use. If you are going to use that value in your program, then only where's the memory, else no need. Okay, this is how we added pulse timer. By considering again the same example, of my pump on, I will use off delay timer now. Okay. Now it's not mandatory that you need to read 4-5 seconds only. You can take the value as per your requirement. Now here there is a bit trick. Pump start, input should go from 1 to 0. That means I need to use this as a push button, or I want to use it as a toggle. Then I need to make it 1 and make it 0 immediately. Yeah? Then only my off delay timer works. If this is not going to be the case, like the input is not I, it is some Q, then how we will proceed? So for that I have a very different thing here available with me. See, scan and trig means negative trig. Output Q is set to 1 at a signal state transition yellow from 1 to 0. Yes. Output Q is set to 1 at a signal state transition from 0 to 1. It is again set to 1. So what I will do is I will make use of some output. Okay, in memory contact, for example 10.0. For example, I will rename it as condition 2. That means a particular condition which happens, and after that only the pump will be on for that particular delay and off it. Okay, now what is my criteria? It should go from 1 to 0. Okay, so I will use here entry. It asks me some memory bit. Sorry. M10.1. Okay, what will happen when it goes to 1? The output will be output Q is set to 1 at a signal state transition from 1 to 0. We want it to be 0. So what will we use? It is 1 to 0. The output will be 1. You can also use P trig based on this condition. Or very basic is you make use of a pulse signal. So you need to make a bit change here. See, entry, that means what it says. Output is 1 in the RLO from 1 to 0. That means this condition should change, then only this output will be high. Once this is high, you can get the output over here. Okay, or else what you can do is you please use P trig. What will happen? Output Q is set to 1 at a signal transition from 0 to 1. Okay, So it is 0 to 1, it will get a pulse. It gets a pulse, and the pulse will be just a prick, and it will get removed by this. So it will also work by using this condition. So now we will move to our last topic, that is but for this you need not to use this condition. It is NO contact. So it's NC, because our logic is like the output should be high. If this becomes 1, then only this should execute. Our objective is not that this should be 0 and then say if N trig is there, you use NC. If P trig is used, you can use this one. Let's come to our last point, that is on delay retentive. Now a very basic meaning of retentive is it will store that value. Okay, so I just drag and drop this. As you are now familiar with this, I will just enter 5 seconds. I need to give some reset input, so I will give 10.1, any kind of input. I will say 1 start input, and see now Q is not used here. Okay, you can use either Q here also, or I will show you another method right now, but I will just, before writing that, I will explain you the working of this on delay retentive. See, on delay timer retentive is when the input goes from 0 to 1, the ET starts. Okay, it starts, but the output is still 0. The input goes from 1 to 0, it is stopped. It goes from 0 to 1, it again starts, but it starts from the value which was stored. It doesn't start from 0, it starts from, for example, we have 5 seconds time. Till 1 second the input was high, and at 1 second it went to 0. Then from 1 second again, after 1 second it again started. So from 1 second only it is going to ramp up, and by that the preset time will be calculated as per the sequence, and when my PT of 5 seconds is completed, then the output will be high. Okay, this is one scenario, that is you change number of times the input, the timing elapsed will be stored, and the timer will resume after your input signal comes back, and will start again from the last stored value only. It is not going to start from the basic 0 value. Okay, this is one point. And the other point is the output will remain high until and unless you give the reset pulse. That is, reset input is very important for on delay retentive. If reset input is not given, the output will remain high continuously. It is not going to change by the input signal. It is going to change only by the reset input signal, not from the input signal. So this is how it was working. Now, as previously stated, I told you, I will explain you that either I can use a coil here or not. For timing, I will show you the coil. For example, we are going to use our output. See, Q0 point. Okay. Now it can be on by this one. I don't want to use this. What I will do? Cut and paste. Take a NO contact. Control C, Control V. See carefully now. I am going to give a dot. click and give a dot. Yes, I can access this. This is a very pretty good feature of TI portal and its timer clock. I really like this. So just go save this, and that's it. This is a complete tutorial on how to use timers in TI portal, or these are very basic timers which are available in all kinds of softwares, all kind of PLC. You take Siemens, you take Mitsubishi, you can take Allen Bradley, overall any make. The basic will remain same. Basic is not going to change. Only thing is what will change, the construction of the block, the blocks in input parameters, output parameter, that is only going to change. The basic working will not change. Okay, thanks for listening.